Hey everyone, today I'll be presenting on cloud native observability, enhancing monitoring and performance. So when we think of cloud applications, the first thing that coming to our mind is SaaS software, probably high volume internet sites like YouTube, Netflix. So in order for these services to be delivered to the customers, the users efficiently, constantly behind the scenes, there are a ton of engineers that are continuously monitoring these services. They're trying to identify potential bottlenecks, optimizations, and basically trying to see what the health of all these systems are, as these systems mostly run on at a data center delivering these services. So let's get into some details of what I'll be presenting today. So we'll go over what is cloud observability, why is it important, some key observability tools and technologies, what are the benefits, best practices. We'll go through some real world use cases, what are our current challenges, and what lies ahead, what is the future of cloud observability, sorry. What is cloud observability? Cloud native observability. The definition is the ability to measure the internal state of a system based on its outputs. In cloud native environments, it involves logs, metrics, and traces. The key components are metrics, which is insights on how a system is performing. Logs is constant events of what the system is running or what it's doing. Traces is the overall flow of that system, how it's part of the overall topology. Where are the requests coming in? Where is it going? So, in a nutshell, it is a way to gather logs, metrics, and traces from a system and using it for monitoring purposes. So, why is observability important in cloud native, in general terms, applications, cloud native services? So, modern services are mostly microservices. As microservices keep evolving, they start getting complicated. Lots of APIs get embedded into it, lots of CRUD operations. There is some level of complexity that kicks into these overall architectures with all the interdependencies across different microservices based on their distributed architecture. In order to get a visibility into those kind of architectures, observability is really important so that we exactly find any performance issues at a specific microservice level or a module. The next one is real-time monitoring. So overall, observability is key to identify potential issues in the system. It helps us gain insights of how the system is actually performing, gets gives us a lot of visibility onto the application based on the metrics or visibility that has basically been configured on different kinds of applications. Better visibility gives us faster issue resolving capabilities. So that's another reason why observability is so important. Covering scalability and performance, it ensures smooth auto scaling and resource allocation. So as we constantly monitor these services, servers, applications, we have better insights. We're better equipped with making better decisions on how to leverage. If the system is constantly running at a high load, it helps us make a decision to auto scale to more to beef up the system more. In case of low utilization, we can always ramp down. So it helps us gain a lot of visibility that eventually helps to design the system better on the scalability aspect of the architecture as well. Same goes with improved debugging. With modern application, modern services, there is tend to be constant issues, performance issues that we try to identify, bugs, probably any customer issues, latency related issues. So with improved monitoring, it helps engineers to identify the issue. So it helps reduce the mean time to identify the issue as well as to resolve the issue eventually. So the turnaround to issue identification to delivering back those bottlenecks issues to the customer is much more faster with cleaner visibility or higher visibility into these services or applications. So some of the key observability tools and technologies today in the modern world is Prometheus. It's primarily used to scrape metrics from different systems, applications. So it collects metrics as well as it helps to monitor those metrics. Grafana is another open source library or visualization that is really popular, getting popular with a lot of third party plugins integration. So it primarily helps in creating based on the metrics that's in some of these backends like Prometheus or InfluxDB. So it helps us query those metrics continuously, have some alerting in place to alert the user in case there are some anomalies or something that exceeds a certain threshold. One thing that's becoming popular is with open telemetry. Earlier, pre-open telemetry, there were multiple vendors in the market. Everybody had their own API or own agents that were constantly scraping metrics or collecting metrics from the applications or systems, building a schema that is vendor specific and sending it to their own backends. So once the user or once the organization is is starting to use that specific vendor, they're pretty much married to that vendor. So in order to port to migrate to a different customer to different vendor, sorry, it's extremely hard. There is very limited vendor portability. So as an industry, everybody came up with some standards on how we collect, not how we collect some of these metrics, at the same time, how we report it back onto the backends. So the backend has a defined schema, which is what is included in OpenTelemetry. It also provides a standardization for tracing across different applications or different tiers of an application to overall stitch how the request is flowing from one tier to another or one system to another system, and giving us a lot more insights into the overall end-to-end picture. So instrumentation is actually the process to instrument the applications via agents. When telemetry is really popular. So Agar is again very popular with open telemetry. It is one of the backends where when you use the agents, you can export it back onto the Agar's platform. So different applications, once it reports into the Agar exporter, Agar has a really smart way to constitute all those different backends and present an overall end-to-end picture of how the request is actually flowing within the system, trying to create those dependencies onto the system. Next is Elastic Stack. It's mostly on log aggregation and analytics, helps in collecting the logs, providing some analytics on top of it. So regarding unified monitoring, the centralized visibility across cloud native environments is very important. Proactive issue detection, adaptable to dynamic workloads, especially on scalability front, is very important. Also, when we say cloud native, it has to be very friendly because modern cloud native software is being delivered iteratively over every 2-3 weeks, maybe once a quarter. So it has to be DevOps friendly. So there should be some kind of continuous integration, continuous deployment model. So the best practice in that is use an open standard, which is OpenTelemetry. Use some Grafana dashboards for visualizations, have some automation in place to find anomalies based on the trend that is being observed on the metrics. Any spikes, anomalies should be quickly detected and reported back to potentially find any bottlenecks or performance issues. So some of the real world use cases I said, as I mentioned, Netflix uses OpenTelemetry for their distributed tracing in microservices. So all the microservices interdependencies is measured using OpenTelemetries to identify potential bottlenecks in across handling the overall requests at which specific microservice there is potential issue. Same with Uber, it implements Agar for end-to-end transaction monitoring. Airbnb uses Prometheus and Grafana for real-time performance monitoring. Challenges, these systems keep getting bigger and bigger. There are more number of metrics being available on a yearly basis as it keeps increasing. So there is huge volumes of telemetry data that gets exported. So the cost goes up, as well as different cloud environments has different ways of presenting the data, different kinds of metrics. So there is standard on the collection part, but there is no standard on the visualization front. So that is future trends. AI driven anomaly detection is a big thing right now. Most of the observability organizations, like vendors, are primarily focused on how to leverage AI, to use AI as a pass-through for every metric, or have some kind of machine learning models to constantly scrape data, analyze, and then report any anomalies. So that is excited to see how that's going to shape up. Similar with more widespread adoption of eBPF for deep observability, as well as increased integration of observability with security tools. So when it comes to security services, not much of it is observable, or there is a lot of restrictions. So in the future, how it turns out for especially security related tools is going to be something to watch out. So that's pretty much it. Thank you so much.